Hello, welcome to Physics 30. I'm going to try to do something new for me anyway, and that is to create a video where I am doing the questions online so that you can see everything really clearly. And anyway, we'll find out. The only problem is I have to write using like a pen, and I don't know, or a stylus, and I don't know how well I'll do. Okay, so just bear with me as I go back to grade 4 apparently and learn how to write again. I posted all the formulas we're going to use up here, and then I'm just going to do questions 4 and 5 to start off with. If you would like me to do some of the other questions more specifically and explain kind of the rationale behind them, I can make videos for them. Otherwise, I'll just post the answers and my work for that, and hopefully you can understand what's going on. So let's begin. And if I look down, it's because I also have the sheet of paper, my work, on the table here. So I'll try to look at the screen mostly, but anyway. We'll see. Rebecca drove her motorcycle to Regina from Moose Jaw using the Constant Acceleration app on her Samsung S10 Plus, not currently available on iPhones. She went from 22.2 kilometers per hour in Moose Jaw to 139.2 kilometers per hour in Regina. So she was going relatively slow in Moose Jaw and then very, very fast in Regina by the time. And she was accelerating at a constant rate, which means that you can imagine the vehicle getting faster and faster, but really slowly. Like the rate of acceleration is really slow here. What was Rebecca's average speed for the trip? What acceleration rate did Rebecca have set on her Samsung if the distance she traveled was 65 kilometers? So she's going from Moose Jaw to Regina very, very slowly. Let's take a look. So that you can see hopefully that there's two parts. There's one part here, the average speed for the trip, and then the acceleration rate. So let's do part 1 first. And I also appreciate that I added some more space here so I could put the answer in, and maybe it's probably not enough room for you to do it all, so just write small. Maybe actually I'll start over here a little bit. Okay, so we're going to call this one, we're going to call this, I'm writing green. Oh well, okay. I was hoping it was going to be blue. So part 1. Oh my goodness. Okay, so part 1. What do we know? We could draw a diagram, but it's just a car that's going from Moose Jaw to Regina. So I think if you can visualize that, you're good. The first thing I notice is 22.2 kilometers per hour, and that's the initial velocity. 22.2 kilometers per hour. Okay. And then when she gets to Regina, she's going, that's her final velocity, her final speed. She's going 139.2 kilometers per hour. Okay. And what are we trying to find out? It says what was Rebecca's average speed? So average speed is V bar, and that's the thing we're trying to find out. This is part 1. Now we could also write down what was the acceleration rate, and she traveled distance of 65, but that's for later on. That's part 2, so we'll just ignore that for now. Now what equation should we use if we were looking for V bar and we have VF and VI? There's really only one equation here that has all 3 of those in, and that can only be used if the acceleration or the change in acceleration is 0, and that just means that the acceleration is constant, which is true. Now the other formula that has it is this one, and that's the change in distance over the change in time. And we do have the distance here, but we aren't given the time. And since we're given these 2 variables here, it doesn't make any sense to try the other one. So let's just plug in the numbers here, or put in the equation. Again, apologize for my penmanship. I need some more practice. Okay, so we know VF and VI, so we can simply, I'm just going to go equals, and I'll put the numbers in. 139.2 kilometers per hour plus 22.2 kilometers per hour, all divided by 2. Okay, and if you do the calculations, I'm just going to look down because I've done this already. It's 80.7 kilometers per hour. Okay, and it actually works out to be exactly that. And there's no other decimals down here. And I got some background music here. I got anyway, 80.7 kilometers per hour. And there's 3 significant digits there. Okay, so there's 3 in this question, 3 here, and there's 4 here, so we use 3. So that's what we're allowed to. Okay, that's part 1. I'm going to change color for part 2. Just going to go to a blue. Okay, part 2. And if you're doing this on your page, hopefully you've written really small so that you have room for this one, because this takes a little bit more room. What is the acceleration rate? So we're asked, so we know all the other things like VI, VF, and now V bar, but we're asked to say what is the average acceleration. And we're given a little bit of more information. That's delta D, and that's 65.0 kilometers. Okay, and so the question now is what equation has a bar in it, because that's what we're looking for. And you'll be happy to know there's only one in here, so can't choose any equations. So a bar is equal to delta V over delta T. Okay. And now the question is, do we know delta V and do we know delta T? If we do, we just fill it in, the values in, and we solve for a bar. Delta V we don't know, it's not given, and so then we look to see what equations have it in it that we haven't already used. Well, this equation we already used, this is the only other equation, so we go over and we go delta V, and I'm putting it to the side here because I want to just substitute this equation for the other equation. And I'm going to go a little bit off the page just because I need the room and because I can't write very small with this technology yet. So this VF minus VI, that I'm going to substitute in here for delta V. So I'm going to rewrite this a bar is equal to VF minus VI divided by delta T. Okay, because I know VF and I know VI. So that's good. Delta T I don't know, and if you look up here, this equation has delta T and this one has a delta T. So I'm going to be using this equation, and hopefully I know delta D and V bar, which indeed I've given delta D and V bar I've solved for, so actually it's going to work out real nice. So let's just take this equation, the V bar is equal to delta D over delta T, and you need to use your math skills to rearrange this so that it's delta T equals something. So how do we get delta T on that side? We can multiply both sides by delta T. Okay, and so now we have delta T V bar equals, and you can put that, I can put that in brackets, I guess, to show it's being multiplied. If the things are together, they're all being multiplied too, but anyway. And then we've canceled out the delta T's there, so now we're left with delta D. Okay, we still want to isolate delta T, so I'm going to get rid of V bar by dividing both sides. The logic behind this is if it's being multiplied on this side, you have to divide to get rid of it. And vice versa, and if it's being added, you subtract. If it's being subtracted, you add it. So we've just rearranged the equation like this. Delta D is equal to, or delta T is equal to delta D over V bar. Now I'm going to take this value here, this part of the equation, and substitute it inside here. So, and I'm just going to move this over a tiny bit. Delta A, or A bar, sorry, equals VF minus VI over delta D over V bar. Just like that. This is a division line. Okay. we have VF, we have VI, we are given delta D, we have calculated V bar, so we now just put it all in there. So I'm going to actually go over here just to have more room. A bar is equal to VF minus VI all divided by delta D over V bar. Okay, and that equals, got a little bit angled there, that equals 139.2 kilometers per hour minus 22.2 kilometers per hour. All of that divided by 65 kilometers divided by 80.7 kilometers per hour. Okay, so you can divide that all out. Make sure that this is divided first before this term here is divided by this. Okay, so just make sure you get the brackets, and I'll just write down what I got there. 145.26 kilometers per hour squared. Now, significant digits wise, we can have 3 significant digits. So we're going to have to say equals 145 kilometers per hour squared. The 2 makes the 5 stay the same. If it was like a 7 here, that would make it 146. But 145 kilometers per hour squared, which probably, if you look at it, you'll be like, that's a really fast acceleration. Because you're used to seeing things like, well, maybe you're not used to any acceleration, but if you are, probably it's in meters per second squared, and like, for instance, the acceleration of gravity is 9.81 meters per second squared. This is 145, so it seems like a large number, but it's 145 kilometers per hour squared. And if you convert that, and you can easily do that on, you can go on Google and just convert it there. It's actually really quite small. It's 0.011, and I'll round to a 2 meters per second squared. So it's actually really slow. And that's what you'd expect. If you're driving from Moose Jaw to Regina and you go from 22 kilometers per hour to 139, it's actually, to do that over the course of the whole trip, like at a constant rate of acceleration, you must be accelerating very, very slow, and so slow that no one in the car would even notice. Okay, so I got like 3 minutes left before I run out of, no, 2 minutes. I have to do this in 2 minutes. Okay, let's see if I can do it. Here, Carter drives his go-kart at a constant speed of 12.5 meters per second for 4 seconds. So we have V bar is equal to 12.5 meters per second. This is speed round. Delta T is the change in time. That's 4 seconds. And we are being asked to say how far, so it's delta D. The beauty of this one is this equation right here. It has all the things that we have discussed. So delta D is equal to, we'll rearrange this. Sorry, scratch that out. Oh, I got an eraser. Let's try that out. Yes. Okay. So we can just say, if I multiply both sides by delta T, we can say delta D is equal to delta T V bar. Now, I did a couple steps all in a row there just to save on a little bit of time here. I have 1 minute left to tell you how to finish this. 4.00 seconds times 12.5 meters per second. So 4 times 12 is 48. 4 times 0.5 is 2, so it's going to be 50 meters. And it should be written with 3 significant digits, so 50.0 meters. Okay, that one was way quicker. This one had 2 parts and a lot of rearranging. This one had a little bit of rearranging. If you're not sure how I went from here to here, you can ask me. But I can only do 15-minute videos at a time with this current program I'm using. Alright, hope that helps. Again, let me know if you want more videos like this, or if you want just the answer sheet. I'll post that hopefully by the end of the today.